Hi, my name is Jessica, and today I am going to present on the utilization of strength training in order to improve running economy. Here is my presentation outline. In it, I will start with an introduction, followed by a discussion of running economy, strength training, distance running, strength training's influence on distance running, some recent studies that are evidence-based that promote and support the ideas that strength training concurrently with running does improve running economy. I'll follow that up with types of strength training to supplement running and practical applications. So there have been a lot of studies out there that have reported that aerobic endurance combined with strength training are detrimental to both energy systems. However, this only appears to be present in cases where the volume is too high, there's too much of an intensity, that kind of thing. But when variables are adjusted accordingly, so the intensity is toned down in strength training, for example, there are improvements, and there's the potential for improvements in running economy. The purpose of this presentation is to use evidence-based research to provide information on how training concurrently with strength training and endurance running can improve running economy for all levels of runners. So as far as economy of movement, or in this case, the economy of running goes, this assessment in order to determine that involves the evaluation of oxygen uptake during exercise at a constant power or velocity output. Those who have a higher running economy consume less oxygen. Typically, any modification to training that increases the economy of effort will improve performance. There are no specific factors to account for individual differences in running economy, although the structure of the muscles themselves and the person's body composition can possibly have an effect. The goal of distance running is to increase the speed and endurance through improving the oxidative energy system. Significant increases in neuromuscular performance are typically not observable in runners because running produces low force levels, which activates fewer motor units than other activities such as resistance exercises. The goal of strength training, on the other hand, is to develop or increase muscular strength or endurance in trained muscle groups. A maximal strength training can reduce neuromuscular adaptations such as hypertrophy. Explosive strength training, such as plyometrics, can result in increased motor unit recruitment, which, as I just mentioned, is a little bit of a lack of in running. Both can improve muscular coordination and mechanical efficiency. Combining these two can improve running economy, as I will show in the studies that I discussed in a couple slides. There is an importance of strength training for runners, believe it or not. There's kind of a misconception with runners that any kind of muscular strength training is detrimental to running. Typically, that's not true. Runners are a group that is frequently injured based on a lot of different factors. Improving muscular weaknesses will improve their performance and decrease their risk of injury. So here are a few brief studies I would like to do an overview of. The first study wanted to determine the effects of resistance training on running economy and performance in collegiate athletes. So there are about 50 male and females who participated. They did a 5-kilometer time trial and some lab-based tests. Then they participated in their season of 6 to 8 cross-country races over the period of about 13 weeks. After the first 4 weeks of their season, they were randomly assigned to either heavy resistance training or plyometric plus heavy resistance. 5 days after completing their final cross-country meet, they came back and completed their post-test. The heavy resistance training produced small to moderate improvements in the peak speed, running economy, and the neuromuscular characteristics, whereas changes in their biomechanical measures were favored by the plyometric resistance training group. The males made less gains than females in both tests. Both treatments could have had possibly harmful effects, and this is mostly because they did start this resistance training while they were in season. So the big thing here to remember is that the females did have a positive effect from the plyometrics, the males not so much, but they were in season. The second study evaluated the effects of 2 training protocols on running economy and some strength parameters in a group of regular training master marathoners. So there were 16 participants who were randomly assigned to a maximal strength training program, a resistance training program, and a control group. So a lot of different measures were taken for this study: resting metabolic rate, body composition, 1 rep max, squat jump, counter movement jump, and running economy. The muscular strength group showed significant increases in the 1 rep max and the running economy. There were no differences emerging from the other groups. So this study shows that master athletes appear to benefit from concurrent strength training and running programs because the rate of force development may be crucial and needed for running economy improvement, which is one of the major determinants of endurance. The third study examined the effect of a short-term plyometric training program on explosive strength and endurance performance of highly competitive middle and long distance runners. The athletes who were in the study were randomly assigned to a control group. There were 12 men, and an explosive strength training group, which was 10 men. They did a depth or a drop jump from 20 centimeters and 40 centimeters, a counter movement jump using their arms, a 20-meter sprint time, and a 2.4 kilometer endurance run. And after 6 weeks of explosive strength training, they conducted their post-tests. There was a significant reduction in their 2.4 kilometer run time, 23.9% decrease, and a 22.3% decrease in their 20-meter sprint time. It was concluded that properly programming concurrent strength and endurance training could have really advantageous effects for middle and long distance runners. The fourth study wanted to determine which mode of concurrent strength training and endurance might be the most effective for improving running performance in highly trained runners. There were 18 highly trained male runners with an average age of 24 and a VO2 max average of 65 or higher. They're randomly assigned into 3 groups, endurance only, so they did their usual training. They included some general strength training with TheraBand exercises. There's a strength group who performed combined resistance and plyometric training, and an endurance group who just performed endurance training, so just running. So this study lasted 12 weeks. They trained 8 times a week, 6 endurance running sessions, and 2 strength sessions per week. And then there were 5 weeks of detraining. Then the subjects were tested 3 different times throughout this period on counter movement jump height, hopping test average height, 1 rep max, and their running economy, VO2 max, max heart rate, peak velocity, rating of perceived exertion, and a 3-kilometer time trial. It was concluded that concurrent training for both the strength and the endurance muscular group led to improved maximal strength, running economy, and a peak velocity. The strength group also seemed to show improvements in the 3-kilometer time tests. So this further validates the idea that combining strength training with running improves running economy. The final study up there supervised periodized mixed maximal and explosive strength training, which is added to endurance training in recreational endurance runners. So this is about an 8-week intervention, which was preceded by a 2-week preparatory period, which was used for building strength. There were 34 subjects ranging in age from 21 to 45 years of age, divided into the experimental groups, which performed maximal and explosive exercises, whereas the control group performed circuit training with their body weight. Increases were observed in both experimental groups that were more systematic than in the control groups. Their explosive strength increased 12% in men and 13% in women. So this can be, the takeaway from this article is that mixed strength training combined with endurance training may be more effective than circuit training for recreational runners. So as far as utilizing strength training for runners, there's explosive strength training in the case of representation plyometrics, which utilizes a stretch shortening cycle, an eccentric contraction followed immediately by a concentric contraction. On the other hand, there is maximal strength training, so lifting a heavy weight, 70 to 90% with low number of repetitions, so about 6 to 8 repetitions. Up here are some types of plyometric exercises. These are mainly for the lower body. These go from low to high intensity as you move down the list. Here are some specific examples of plyometric and strength exercises. Most of these, as you can see, are for the lower body. There is a clapping push-up, which is an upper body chest exercise. Okay, now I'm going to show you a few exercises, plyometric exercises. Okay, here is my first plyometric drill I would like to show. This is a tuck jump. So as you're watching it, keep in mind that when the athlete or runner is performing this exercise, that they drive their knees up to their chest in midair, laying squarely on their feet, dropping their butt to the ground to soften the landing, so there isn't as much force on the knees. If an athlete cannot land softly, they can move on to a squat jump, which has a little less impact. And here we get a slow motion version, so the knees don't go over the toes. Okay, here is the second plyometric exercise, a squat jump. As I said before, if the tuck jump is a little too much for someone, they can try the squat jump. Again, they're driving the butt towards the ground before coming back up into the air, exploding upwards to reach maximal height, coming back down, landing squarely on the feet, absorbing the force more in the glute muscles and not in the knees. And again, we have the slow motion version. Demonstrates. Lastly, we have the lunge jump, or also called the split jump. The front leg, when landing, should have a 90-degree angle in it, as you will see in a moment, as well as the back leg. The back leg doesn't have to touch the ground upon landing. About 2 to 3 inches is sufficient space between the leg and the ground. And try and minimize that force by taking that force into the glutes and not into the knees. As far as what should be done, what shouldn't be done, my own personal recommendations from what I've read in various literature is to do about 2 to 3 sets of 6 to 8 repetitions at about 70 to 90% of 1 rep max. This also depends on the time of periodization If a person's in season, they're not going to go towards that high percentage of their 1 repetition max. Plyometrics, on the other hand, is gauged through period of time or repetitions. So 3 to 5 sets of 20 to 60 seconds per exercise. Some people do repetitions, for example, a split jump doing a certain number. Others do it by a time trial. As far as the practical application of using this information, personal trainers, coaches, a ton of people in exercise science professions can benefit from this information, especially those who work with athletes of middle to long distance and want to increase their strength, their power, their overall running economy. Athletes as well can benefit knowing this personal knowledge going into their training, and even recreational athletes will benefit if they're training on their own. Thank you for watching my presentation. I hope you learned a little bit about how strength training improves running economy and that you can apply it to your own life or someone that you know.